Welcome to the second part of Debbie Stevens-Gill's Test Fairness and Utility in Research and Applied Sessions setting. This is part 2 of the 7 PS 003 Conducting and Interpreting Research by Debbie Stevens-Gill. My name is Dr. Penelope Smith-Lee-Chong, and I am doing this podcast for Debbie. So the second part, as I said in part 1, is expectancy tables and utility. Oops, just a moment. Expectancy tables and utility. So what are expectancy tables? Just a moment. What are expectancy tables? Expectancy tables is a table showing the probability the test scores in a particular test range will result in successful job performance, and they're useful for demonstrating the validity of tests to managers. So that can be extremely useful then when you are, as an occupational psychologist, you're working in a business and the business doesn't, you have to convince them as to whether or not to use selection tests. So demonstrating the validity to managers is really important, because if it's going to show that the people that they hire can be successful people, then they would want to have selection tests. It can also be used to visually illustrate the impact of cut-off scores on hiring decisions. So I'll show you an example now of an expectancy table. So using validity coefficients of a test, we can use regression to develop tables that predict outcomes. So for example, we can predict what someone's score will be on the end of a training test. That is how successful they will be based on their psychometric scores, which is of course going to be very valuable to businesses because they want results. This next example isn't a very good copy, but a clearer version of this can be found in the Casico and Aguinis. It's a top-down approach is likely in this type of table. Moving on now to utility analysis. Utility analysis is the cost-benefit analysis of testing. It puts a pound or dollar value on the cost or benefits of using a test. And there are a number of approaches which will be shown. Some of them will be shown on the next slides, which are available. Again, you can see why businesses would be interested in the utility analysis approach of things in terms of money. So the first one we're going to look at is the Taylor-Russell tables, 1939. So this indicates the success expected through the use of a test of a given validity. So it estimates the percentage of future employees who will be successful on the job if a particular method is used. And there are 3 conditions needed to get the maximum gain of a test. The validity is high, there's a low current success rate, and there's a high degree of selectivity as possible. Another way we can do it in terms of utility analysis is through regression. So this is where we have a few stats come in. You can estimate the person's score in the standardized score units. These things will become more familiar to you, or maybe you've covered them before. But if you look at this, Z with the subscript Y is an estimate of the person's criterion or the job training performance in standard scores, whereas ZX is the person's standard Z score on the test. So what happens then is a test correlates a plus 0.47 with success in a computer programming course. This is a worked example of a Z-score here. So the Z-score is obtained by using the correlate of 0.47. So that's the validity coefficient multiplied by the person's standard Z score on the test. So that what is the predicted performance of a person scoring 40 on the test, where the mean is 30 and S equals 5. So this is how it's worked out. So the predicted performance is equal to 0.94 standard deviations above the mean. And then we can convert that Z of plus 0.94 to raw score if we know the mean and the standard deviation of the performance scale. So here, as you see, if we know the mean and the standard deviation of performance scale, then the performance rating would be 64.1. And we can also calculate a band of error around this forecast, which is known as the standard error of estimate, or SEE. So they're saying that there's a probability, there's a 68% probability that the person's criterion score is plus or minus 0.88 around the plus 0.94. That is plus 0.06 to plus 1.82. So that person's score is going to lie within that range. So this gives predictive data on performance, which accounts for potential error. So in reality, this might translate to performance data, such as sales or production data. So this is about how a person in sales or maybe production might perform, and it calculates the measure of error around the performance scores as well. Another type of utility analysis is the Broden-Cronbach-Glaser utility equation, where basically it is benefits minus costs. So cost is subtracted from benefits. So in service industries, it's much more difficult to give estimates of hard data. So we can estimate utility in terms of how much money a good selection process, including psychometrics, would save us. And this relies on estimations of job performance from managers. So you can see the tricky bit there, because if it's relying on job performance from managers, research by Moyers and Carstairs has shown that this is notoriously unreliable because it's going to be subject to bias. But the persuasive power of these equations is very useful because businesses like hard facts, and they would see this as quite a powerful equation. An example now is looking at how this cost-benefit analysis has worked is in Schmidt, Hunter, McKenzie, and Muldrow. They used a computer, a programmer aptitude test to select 618 computer programmers, and that saved $37.9 million over the time those employees were with this company. So you can see how beneficial that would be to the business. Another example is Casio and Ramos in 1986. They used an assessment center to select 1,116 managers for telephone company. And there the utility was 20,723,894,000 US dollars. So that really ends the part 2, the expectancy tables and utility part of the test fairness and utility in research and applied settings, and this will be available on YouTube. Thank you for listening.